the whole session. Thanks. Yeah, okay. You can also send me, if you have some questions or maybe technical difficulties, you can send me a chat message directly, and then I can answer that. The first thing, or this webinar is in two parts. First, I will give just a short introduction for the project, so all the people know where we're coming from, what the project in itself is about, and then our colleague Ties Lammens from BTG, the Netherlands, will show you one part of our tool set, and he will show you the Bio2Match tool, which guides you to, or which guides the user to the optical matching between biomass resources and conversion technologies. My part will be really short, maybe 5 minutes, and then Thies has the floor. And probably the best is if you wait with your questions, if they are not really urgent, until Thies or me are finished, and then we will, you can then question and give your questions, and we try to answer that. Some of the colleagues from the project are also within the attendees, so yeah, we are quite sure that all the questions you are giving to us we can also answer now. So then I will, any questions to that schedule or the timeline? If not, I will start with a project presentation. Short one you already have, you see, so the project title is Delivery of Sustainable Supply of Non-Food Biomass to Support the Resource Efficient Bioeconomy in Europe. My presentation is just as, the content will be show you the S2Biom at the whole, then our objectives, project partners, and a bit about the thematic structure of the project. Here you see our main objective is support the delivery of sustainable supply biomass for the bioeconomy in Europe. It's funded under the 7th framework program. The funding volume is 4 million euro. The duration is now 39 months. We got an extension, and it will run until November this year. We are 31 partners from 16 countries, and all the latest information you can get from our webpage, which is s2biom.eu. The objectives, first, analysis of biomass potentials and respective conversion pathways, where you will see a part of that analysis today with a presentation of the tool. Also analysis of the political and policy framework conditions and applications of sustainability criteria in EU 28 and neighboring countries, development of transnational strategies, roadmaps, and toolbox to support a resource-efficient bioeconomy in Europe. And then the part which we are kind of showing you today, or one of the tool sets, is a development of a web-based interactive tool and materials for support of the economy, research, and policy for local, regional, and national stakeholders. Just to show you some, or the partners involved in this project, you can see them here. The thematics, the structure of the project is we have 3 themes. Theme 1 is separated in 4 work packages. First one is to gather the information about the sustainable biomass and cost supply data. Work package 2 is about biomass conversion technologies for energy and bio-based products. Work package 3 is optimal logistics for sustainable non-food biomass feedstock delivery chains. And work package 4 then integrates it into the toolset for interactive biomass supply, demand matching in sustainable biomass value chain. chains, and where you will today see the biomass supply and demand matching tool, which is presented today. Then we have theme 2, which mostly is about the regulatory framework, the financial framework, the sustainability assessment and development of vision and strategies. It's also separated in 4 work packages. Work package 5, value chain sustainability across the bio-based sector. Then we have work package 6, which deals with regulatory and financial frameworks in order to mobilize the non-food biomass and bio-based products and the bioenergy market. But work package 7 is an integrated assessment optimization for biomass supply chains in order to satisfy the demand. And work package 8 then takes it to an integration step. So in development of a vision, strategies and implementation plans, and also an R&D roadmap. Then we have theme 3, which is work package 9, 10 and 11. Work package 9 is mostly about regional adaptations, applications, user integration, testing, validation and implementation planning. Work package 10 is about stakeholder engagement, cooperations with other initiatives, and dissemination and exploitation of the results, dissemination activities. Work package 11 is then the project management. Yeah, the project coordinator, oh yeah, I forget that. Me, Ludger Wenzelidis from FNR, I am the project coordinator for this project on the administrative level. And Calliope Panutsu from Imperial College in London, she is a scientific coordinator for the project. So, and if you have any questions, just give us an email or phone call. We will then direct you to the responsible person or directly answer your questions you have for the project. Thanks very much for this. This was my presentation about the project in itself. And I would then go over to Thies and give him the presenting tools, and he then can start with his presentation about the Bio2Match tool of the S2Biom toolsets. Thanks very much.
Okay, thank you, Ludger.
Okay.
If all works well, then everybody can see my screen now. Is that correct?
I can see
Ludger?
it, yeah. Yeah, I can see it.
Okay.
So
okay.
I hope everybody else too. If not, please give me a chat message, then I see what we can do.
Okay, so what you can, so basically, yeah, good morning. My name is Thijs Lammens of BTG, Biomass Technology Group in the Netherlands, and together with Wageningen University, we developed a matching tool to match biomass and conversion technologies. We call it Bio2Match. What I want to do in this webinar is first I give you a very short introduction, and actually Ludger already gave an introduction about the project, so I will keep it fairly short. Then I want to describe the methodology of the tool and how we match biomass and technologies based on what indicators. I will shortly describe the databases that underlie the tool, a technology database and a biomass properties database. I will show you based on print screens first how you can use the tool, and then I will go to a live demonstration of the tool. And then hopefully we can have some questions and discussion and perhaps some feedback. So first, the introduction. The rationale behind this tool and basically behind the whole project of S2Biom is that there's a lot of biomass available across the EU. However, if you have different regions within Europe, then you have very different types of biomass that are available. For example, Norway compared to Greece, they are very different types of biomass, and these types of biomass have different characteristics. Also, different regions demand different products. So then, if you want to optimize that, the resource-efficient use of biomass at EU level, it's quite challenging. The idea behind this tool is really to support stakeholders in the bioeconomy with a tool in which they can see, okay, this type of biomass can be converted by a certain type of technology to certain products. And the other way around, if you have a certain technology, okay, what types of biomass could be used with it. In order to develop this tool, we first came up with a classification system and for the matching, and that's basically based on different types of conversion processes. So you can see that here on the right side you have thermal conversion processes, biochemical and chemical conversion processes, and anaerobic digestion are the three main classifications that we came up with. And these different conversion technologies, they require very different aspects, characteristics, or qualities, however you want to call it, from a biomass feedstock. So these we've called thermal quality, biochemical and chemical quality, and anaerobic quality. And I'll describe that in a bit more detail across the rest of the presentation. So these kind of main qualities is what we call sort of the fundamental properties of biomass that are fairly difficult to change. There are also some more easy to modify properties or physical characteristics like moisture content, density, etc., that you could adapt with a basic treatment. And these we've taken separately. Because it's in the matching tool it can give some different results, but I'll show that in a bit as well. So this is the methodology how the tool couples the different quality aspects of the biomass and the criteria of the technologies. What you see here is you have a biomass database and a technology database. They provide the input for the tool. In the technology database, we've defined for the technology what are the criteria that biomass needs to meet in order to be able to be converted. And for the biomass, we've defined all the properties, all the biomass characteristics. And then what the tool does is initially compare these to see if there's a fundamental match. So these are based on the main quality indicators, so the thermal, the chemical, and the anaerobic qualities of the biomass. And then if there's a yes, if there is a match, then we look at, okay, so is there also a physical match? So for instance, can the technology handle a certain moisture content, or does it need to be different? If it's yes, then the tool will give you a match between a biomass and a technology. If not, if there's no fundamental match, it will give you a no. Across, and if there is a fundamental match but you need some basic treatment in form of drying, for example, it will give you sort of an exclamation mark that you need to take this into account. Then these are the quality indicators that we used for the matching of biomass and technologies. So again, you see the three main classes: thermal, biochemical and chemical, and anaerobic digestion. And then for the thermal quality, we look at the chlorine content of biomass, because it's related to corrosion mostly in equipment. We look at ash deformation temperature of the biomass, because that's related to slagging and fouling in your equipment. Ash content is related to product yield, processability, costs, etc. So it's an important parameter as well. And also we look at nitrogen content, and that's related to NOx emissions, which could potentially really be drivers of cost or feasibility of a certain technology. In terms of chemical and biochemical properties, we look at basically the carbohydrate content, so cellulose plus hemicellulose. We look at the lignin content, as that's an indicator for processability. And again, we look at the ash content of the biomass. And for the anaerobic digestion, we look mainly at the biogas yield, and also whether the digestate can be applied or whether or not. And then for the physical properties, of course, there's lots of different physical properties you can take into account. We decided that the two major ones, most important ones, are moisture content and the density, the bulk density. So these are the two ones that we've taken into account in the tool. Then how this works basically is because biomass, well, the qualities for a certain indicator it's not a set number. It depends on seasonal variation. It depends on do with fertilizing, for example, when it's harvested, etc. So we use ranges in the tool and define basically 4 different quality classes for each property. And what you see here is the example of ash content of a certain biomass. And then you see the class 1 is what we call the ideal biomass. It has a very low ash content, so below 1 weight percent. Class 2 is the desirable biomass with an ash content between 1 and 3 weight percent. Class 3 is a bit more difficult to process, so sort of undesirable biomass with a high ash content of say 3 to 10 weight percent. And class 4 is then the very undesirable biomass, really difficult to treat if it has a very high ash content above 10%. And then for the technologies, we've defined for each of these properties that I just mentioned, for example, ash content or chlorine content, etc. We said, okay, a technology is able to handle biomass of, for instance, only class 1 and 2, so only good quality biomass, or some technologies are able to handle any type of biomass, or some technologies may only be able to use the ideal biomass. And in this way, by using this classification system, you can see if there's a match, or if a technology is able to handle a certain type of biomass. But also what you can also see is, and I'll come back to that in the demonstration as well, if a certain technology can handle all qualities of biomass, so also very high, very undesirable biomass, that's for example very high in ash content, then, and your biomass is that you want to use, that you want to match it with, is ideal biomass. Well, maybe then it's not an optimal solution, and you can optimize it in a different way. So also, if a technology can use lower quality biomass than the one you've selected, you can get it from this tool as well, that kind of information. Then about the databases. First, the conversion technology database. Well, this is what it looks like on the internet. So this is sort of the main screen where you have lots of different entries with types of technologies which are characterized in, for example, direct combustion, and then you have a subcategory and a certain specific name for a technology. What you can do, you can click on one of these entries. And then you can basically access all the information on these technologies. What you see here is the sort of the main platforms that we defined. So direct combustion, gasification, syngas platform, specifically fast pyrolysis, torrefaction, and these are sort of the and treatment in subcritical water is what we call the thermal conversion technologies. Then the techniques from pulp and paper industries, chemical treatment, hydrolysis, and fermentation is sort of the chemical and biochemical, and then a separate category is anaerobic digestion. And then if you click on a certain entry in the biomass database, then you can get this screen, and I'm not sure if it's readable entirely on your screen, but it's yeah, what you can see here is lots of information on this technology. And so, for example, a description of the main operating principle, level of commercial application, technology readiness, what kind of outputs are there, what kind of products and how much of them, conversion efficiencies, also some financial data, typical investment costs for such a unit, labor requirement in the sense of the number of FTEs that you need to operate it, and of course the feedstock quality criteria that feed into the matching tool. Then there's also a biomass properties database, and this has been prepared by experts from within the consortium based on literature. So lots of different biomass property data have been gathered, and basically we have about 50 different biomass types of biomass in the database. It's all lignocellulosic biomass, by the way, so, and it's forestry biomass, agricultural biomass, other land use, so for example landscape maintenance and grass from roadsides, etc. Industrial residues and consumer waste are all in there. And then the database contains the typical values of a certain quality. So for example a certain percentage of ash, the typical value of it, but also high and low values. So it gives you a range of contents of a certain ash content, for example. Then I come to the tool, Bio2Match. This is the user interface, and I will show it in more detail in the demonstration. What you see here is all the different biomass types that are in the database in the tool, and you see lots of conversion technologies, and then you can select which ones you want to match with each other. In this screen you then see the match, so which ones match, which ones don't match, and which ones need some pre-treatment. If you click on a certain one, a certain match, then you see all the details. So here you see the 4-class system that I described before. So what you see here is, for example, for ash content, the blocks that you see is what a technology can handle. So here we've selected a grate boiler that's been designed for wood chips for combined heat and power as a technology, and that's able to handle a ash content of quality class 1, 2 and 3, but not of class 4. So that one is red. And then the biomass that's selected here, that's you can see here, it's cereals, straw. That typically has an ash content between 3 and 10%, so that actually matches with what the technology can handle. So that matches with what the technology can handle. But if you then go to ash melting behavior, the technology can only handle classes 1 and 2, but here the cereal straw is of class 3, so that means that the biomass cannot handle this ash melting behavior. The technology cannot handle this ash melting behavior of the biomass, I have to say. So you will get lots of slagging and fouling with this specific technology, so that there's no match. So that's where you can see all the details of the specific match between biomass and technology in the matching overview. And then there are several specific optionalities in the tool, which I will describe further in the demonstration. So how you can work with it, you can go to www.biomasstools.eu, also through the S2Biom website you can go here, then you will see this screen. Initially, so you can always visit it through biomasstools.eu. What you currently will see is a temporary email address that this one will link you to, but this is the link that you can always use to access it. Then you need to sign in to the toolbox. You can use the screen name demo and password Helsinki with all small letters in order to sign in. And then you can click, here's all the data, you can click on tools and Bio2Match, and that will guide you to the matching tool. For the technology database, I will show that in the demonstration as well. It's also in the toolbox, but then not under tools, but on under biomass chain data, and then here you see conversion technologies. You can click on that, and then you see here at the bottom of the screen, you see what I've showed before already, and then you can select a certain technology. You can click here on the top to order all the different technologies. And here on the right side you have a viewing icon, and you can click on this one to view all the data of a certain technology. So let's go to the demonstration, biomasstools.eu again. I have it here. So here you see again the same user interface. I've already logged in, so you need to sign in here with Demo and Helsinki in order to be able to access the tool. And then under Tools, here you can find the Bio2Match. So the first thing I want to show is user instructions. Everything that I say you can also find back in our user instructions. So there's a PDF file with well, general information, and I'll just scroll through it quickly to give you an impression. It gives you all the information that I've just shown, so you can read it later on if you want to play around with the tool. So back to the tool. Again, you have, I will first quickly run through all the different panes, and then I will show you how it works in a bit more detail. So again, here you have your conversion technologies. You have all your different biomass types. They are ordered in the platforms that I described. So there's a drop-down menu. You can click on one, and then you can see all the different specific technologies that are in the database, and then you can select certain ones. The same for the biomass types. Also here there's drop-down menus in the different classes, and then you can see all different types of biomass. So for example, here I've selected already a cereal straw and two different technologies. If you say, okay, well, this is not very readable, I want to have it the other way around, you can switch rows and columns with this button here at the top. And then it needs to calculate a bit. Let me try that again. Okay, so here we are. I think my internet connection is a bit slow, so okay, let me try this again. I'm going to switch the rows and columns. Here we are. Okay, so now you see, now you have the technologies here in all the different rows, and you have a column with the types of biomass. You can play around a bit with the screens so that it becomes a bit more readable. And if a certain technology, for example, is not entirely readable, you can always click on it, and then you get in this gray screen you get the specific description. So it depends a bit on the resolution of your computer screen if you want to expand it a bit. So again, here you see the selected biomass I took, so cereal straw, and you see two different technologies that I selected: a great boiler that's designed for wood chips for combined heat and power, and a great boiler that's been designed for agro biomass for combined heat and power. And then if you click on one of them, so for example on this one, then you get at the bottom in the matching overview, it shows you all the different quality indicators that are relevant for this technology, and it shows you, as I've just shown as well in the presentation, it shows you which quality classes a technology can handle. These are the different blocks. So if they're green, the technology can handle it. So this technology can handle quality class 1, 2, and 3, and cannot handle quality class 4. And this specific biomass, cereal straw, is for ash content it's quality class 3, so that's fine. However, for ash melting behavior it's quality class 3 as well, but the technology can only handle quality classes 1 and 2. And so you can go through all the different matching indicators. If one of them is red here, so if there's one indicator that gives a no match symbol, then in the main screen it will show that this technology and this biomass do not match. Here you can also see if there is a match, you can click on it and you can see here indeed everything is green. So this technology and this biomass type do match. So what you can do is you can, for example, if you want to compare certain technologies and certain types of biomass, for example, I can select some stem wood from conifer trees as well, and I can select another technology, for example, well, ethanol from lignocellulosic biomass. Then you can see some more. So in principle, you could select everything, but that gives you very unclear viewing here. But you can select a couple of them and then compare it, and then you can see, for example, if you have your great boiler designed for wood chips for combined heat and power, it can run on thinnings from conifer trees. It cannot run on cereal straw. While if you want to prepare ethanol from lignocellulose, well, it's more designed for straw type of biomass, so it can handle this, but it cannot handle that. And on the other hand, you have your great boiler that's designed for agrobiomass. It can handle the cereal straw, and in principle, it can also handle the wood chips. However, if you look at it in detail, you can see here at the bottom, so it's all green here, only moisture content of the biomass. If you have fresh wood chips, it's around, say, 50 to 60%, and this type of technology typically can handle only drier biomass, which gives you a warning signal that, okay, if you have a certain unit that's designed not for wood chips, but for this specific unit designed for agrobiomass, then you need to dry your biomass before you can process it. Well, if you then say, I'm not interested in a certain quality indicator, so for example, I don't care about these physical pre-treatments, I don't care about moisture content, and I don't care about bulk density, then you can unselect these quality characteristics, and then for each one you unselect or select, the tool will recalculate if there is a match or not. So now you see, because I unselected these physical characteristics, now you see that for this one it gives a match. And also, for example, if you say, well, the conversion technology that we have in our database here, a great boiler with wood chips for combined heat and power, that can handle for ash melting behavior classes 1, 2, 3, and 4. If you have your own, for example, if you're a technology developer and you know that your own specific great boiler can actually handle these as well, then you can, for example, say, okay, well, I'm not so interested in this one, so you can select a thermal conversion. You can, for example, unselect ash melting behavior, and you can then you will see. Sorry that I have to scroll around a bit. That's again related to the screen resolution that I have now. Then you can see for the cereal straw. Now these ones are unselected, so they become gray. So you see they're not taken into account, but still there's one red here on chlorine content. So if you say, well, I don't, my technology can handle very high chlorine contents as well, for example, then you can also unselect this one, and then you see, if you select this one again, then you see, because only the green ones are taken into account and the gray ones are not, then you can see now it gives you a match. So also if you are an expert on a certain technology or a certain biomass, then you can select the characteristics or the indicators that you think are relevant. You can do that yourself. Another feature is this one. It's product groups. If you are interested only in a certain type of product, so for example, if you're only interested in biofuels and bio-based products and you don't want to make electricity or heat, you can unselect these. And what the tool then will do, it will filter basically the conversion technologies and only show you the conversion technologies that can actually produce biofuels and bio-based products. So for example, direct combustion of solid biomass is now not an option anymore to select. And also here we had two options that created heat and electricity, and one option that creates ethanol, which is a biofuel or a bio-based product. So this one is still here and the others are not. Then the last feature I want to show you is this screen. It's the regions filter, and in order to do this, it's linked with another part of the database, of the toolset of S2Biom. So if you go here to biomass chain data and you go to biomass supply, it takes some time to load, so I preloaded it here, but then you get this screen, and then you get a map of Europe with all the different countries. I don't want to go into all the details of this specific tool, because there's another webinar has been hosted for that. But you can select a certain country, for example here, Sweden, and then you can go here and look up biomass types that are in this country in the biomass and technology matching tool. And if you do that, it will automatically filter somehow this went wrong, but normally you would see here in the regions screen, let me try that again. So I'm going to select a country and then look them up. Okay, now you see it here. So I will click this one away. So you see here in now Sweden, only the biomass types that are available in Sweden are selected. So certain biomass types won't pop up anymore in this one. So for example, you had some olive tree residues, or cuttings, etc., that are not in here anymore. So basically, in this way, you can, if you're interested in a certain region, here in the biomass that's available there, and what the type of tools that you can use to handle it, that's why we linked these two tools. And then you can say for a certain region, okay, well, these types of biomass are available, and I can connect them with these kinds of tools, this kind of conversion technologies. Well, that's basically how this tool works. So let me put this one away and this one away. And then the last thing I want to show is, okay, so I'm interested in a certain technology, for example, ethanol from lignocellulose. Then you can, I'm going to select it here. Here you can see for each of the technologies here there's a number. So here it's number 65, and that's an indicator you can use to look up this technology quickly in the database. So here I've shown before, you can go to the database of conversion technologies, and now here you see all the numbered entries. So you can go to number 65 here, and then you can click on the view icon here on the right side, and that will give you all the information that's in the database on this specific technology. So here we're talking about ethanol from lignocellulose. Well, that describes you a bit on the operating principle. It will show the level of commercial application. So worldwide there are now about 10 commercial scale cellulosic ethanol plants, etc. So lots of information here. You can see something about the outputs. So ethanol, typical output in terms of how many cubic meters of ethanol per hour, the amount of power so electricity that the plant produces as well, external inputs that are needed for this specific plant, typical full load hours per year you can find. So you can find lots of information here about this technology, and it's clustered in basically the general properties of the technology, the technical properties, and also again the biomass input specifications, which are used for the matching of the technology. And then here at the bottom you also see the financial and economic properties. So this you can all find in this technology database for all these different technologies. So just to give you an indication, there's lots of them in here. So that was for now the demonstration of the Bio2Match tool. I've shown that you can select different conversion technologies, you can select different biomass types, and then here in the middle it gives you the match, which technologies match to different kinds of biomass. At the bottom, if you click on a certain technology, you can see why there is a match of why there is no match. You can play around with the indicators that are used by the tool to do the matching, but my advice would be the default is that you use all the indicators because that's based on the experts that developed the tool in the S2Biom project. But if you are an expert yourself and you have a different opinion, of course you can. We made it a bit flexible for you. You can look at different product groups, you can look at different regions. Yeah, and with that it gives you quite a good idea of sort of the general characteristics of different biomasses and different technologies and which ones can work with each other and which ones can't. So that's been my my presentation for now. Let me just put this up. Here's my name and also my contact details. If you have any specific questions of the about this tool or about stuff that's in the database, etc., or you have feedback, you think, well, a certain technology, there's some parameters should be different, or about biomass, etc., you can always contact me through email or by telephone. So that was it for this demonstration. If there are any questions or feedback, I would be very happy to receive that. So feel free to ask any questions you have.
Thanks very much, Thijs. Yeah, as he just said, if you have questions, please, give them to us.
Rutger,
yeah.
This is therein.
Yeah.
There's one remark I would like to make, and that is that I encourage everybody to go to the toolbox, but I would advise people to sign in and make their own login, ask for their own login information.
Yeah.
I mean, if you sign in, then you can make your own username, because then you also have access to other tools in the toolbox.
Okay. So don't use the generic login information we just gave you, but you can apply for your own.
Well, you can use it, but then you will only see part of the toolbox.
Yeah. If you want to see the whole thing, you just apply for your specific username and login information, and then you will get it, and you can then log in with your own name and password.
Yes.
Thanks, Barry.
Okay, and for that people can contact either me through the email address that you see, or you can go through the S2Biom website to get information there.
Okay, so any other questions or remarks from your side?
Hi, it's Ilse. I have another remark. So the presentation that Thijs just showed, it's already uploaded on the website of S2Biom. So if you want to download it or to have it, then you're welcome to go to the website, and under the news and events section where was the announcement about this webinar, you will also find a link where you can download this presentation.
Okay, thanks very much for that.
Yeah, so if there are no questions now, I would encourage everybody to just go to the toolbox, play around with it, and see if it fits your expectations, if it's useful to you, etc. And if you have any questions at a later stage, then you can always contact me for them.
Okay, yeah, that's probably the best solution then, if you don't have any questions right now. Okay. No remarks and questions at the moment. So then I can just say thank you very much for your attendance, and thank you very much, Thijs, for this presentation. Oh, I see Ingo, you wanna?
Yeah, well, actually, I just wanted to thank you as well for the presentation. It was very interesting, and
Okay.
as Thijs told us, I will try this tool.
Okay, okay, great.
Okay, thank you very much.
Yeah, thanks very much. And yeah, as already mentioned, go to our website and you can directly contact us via the email addresses or telephone given. But you can also go to our website, and there you will find also the information you need if you have questions for that. Yeah. If there are no more questions or any questions and remarks now, I will just end this webinar. Thanks again for it, and have a good day. And yeah, we hope to get some feedback from you via email or telephone, whatever. But yeah, thanks very much for that, and have a nice afternoon probably, or yeah, nice morning and nice afternoon.
Yes, also on my behalf, thank you all for attending. Yeah.
Thanks very much.
Okay. Thank you very
Bye.
much.
Okay,
Bye.
bye-bye.
Bye-bye.
Thank
Bye.
you. Bye-bye.
Thank you. Bye.